Now here he is running a test in the yard, and he is showing, he's tethered to the ground in the first place here, and I think you can see to the left of the machine along the fence there a cable. That cable is holding the machine. We do not have the beautiful shiny tail boom anymore here because, of course, we lost it in the wreck. But here we have a welded structure instead of a tail boom, and the back end of it is attached by a cable to the man over by the fence holding that dial there. There you can see the method of measuring the torque, and since we know the force there and hence the torque, we know the RPM, we therefore know the power very exactly. The engine is 165 horsepower, 6-cylinder opposed Franklin, and much to their embarrassment, we were always able to check up on the power output of the engine. At the same time, we wanted to know about our lift, because all our calculations on the performance had been extrapolations from model data. So naturally, we were anxious as early as possible to find out how we were doing. Arthur had learned to measure performance of models in a hover very accurately and beautifully with apparatus that he had developed. And he tried a tremendous variety of airfoils and combinations of RPM, solidity, and so forth. But nevertheless, extrapolating to full-scale Reynolds numbers, we were very anxious to double-check. And incidentally, we had built two different transmission ratios. One was 9-to-1, and the other one was 10.5-to-1. Here is the Chatillon scale, which is measuring the excess thrust. Now, we move a month or two later to May of 1943, and the pilot is no longer Arthur here. This is Floyd Carlson. He was a young man who had been hired as a test pilot for Bell's fighter planes and had been assigned to the project even before we got to Gardenville, or at least shortly after we got to Gardenville, I guess. Floyd immediately learned how to hover as soon as he tried here, and you can see that we have excellent hovering stability. He is tied with the cable to the ground, and you can see the trapeze there attached to outriggers above the center of gravity. But even though he's able to fly the machine so well, Arthur didn't want to let him fly free yet, perhaps because of our accident. He felt very conservative and wanted to be absolutely sure before Floyd could fly in the sense of going from one place to another without that cable underneath him. Here, Floyd's going to do the first 360-degree hovering turn while Arthur watches from the ground. This control system I'll tell you a little more about now. Floyd's left hand there is on the pump handle collective. He has no rudder pedals. His left hand, when it moves horizontally, controls the pitch of the tail rotor and hence the direction of the machine, whereas up and down was collective pitch of the main rotor. His throttle is on the cyclic pitch in his right hand. Now we have a shot from the roof of the garage, and you see that he's about out of ground effect. He's going to be able to wave at us a little later because the collective pitch forces are balanced. Now, we tried many different control systems, at least a half a dozen, but this particular one is the one that was used at first for all the free flights, and 6 of us learned to fly this machine by this tether technique with no rudder pedals. He's going to wave at us there, and he gets the machine pretty well buttoned up right after that. Now here is a scene very reminiscent of that model scene where Arthur tried to shake the model by shoving its legs, and sure enough, of course, full scale is equally solid. It turned out later we almost had too much hovering stability, but this certainly was spectacular and very nice at this point, especially since Floyd had to learn on his own hook what the characteristics of the machine were. It was very nice to have it respond so slowly. Now we're going to see the more details of the actual structure that was used on Ship 1. This project was known as the Gardenville Project, and the helicopter was known as Model 30. Now there's our first rotor brake. You can see that spring is really here. We're in June of 1943. Notice as he pulls the pitch up and down that the stabilizer bar itself moves up and down. It's driven by a separate outer tube from below because the rotor is clamped to the mast. The device, which you can just barely see through the bar there, is an enormous clamp so that the mast did not have any splines or stress raisers. The only way we drove it by the transmission was a brazed piece at the bottom which had splines on it. In this way, we felt that we had a reliable structure with uninterrupted path for the large force of torque. There's the cyclic pitch, which is very conventional. Inside the bar are mixing levers here, because we do not have the flywheel, of course, and so Art had no way of controlling the helicopter by pilot motion unless he introduced levers inside the bar. They're called mixing levers. At the time we called it the fixed stick control. And in that way, that was the first major invention that had to be added after we got to Gardenville and before free flights could be made.